Hi, so today in this video we're going to be covering chapter 6.4, which is algebraic analysis on the properties of logarithms. So let's see. It looks like in this video we're going to be learning about how to expand and condense logarithms using the properties of logarithms. So there are a few things that we need to know concerning the laws of logarithms, the properties of logarithms. So firstly, whoops, hold on, let me make a new layer. Log base 5, we'll say x, no, we'll say m to the x plus log base n to the y is exactly the same as log, actually we want the bases to be the same, log base m to the x times y. They need the same base. Log base m to the x minus log base m to the y is the same as log base m to the x divided by y. These are really great to have in your notes, so I recommend if you haven't yet, write them down. We also have the 3 log, we'll say the n log to the m to the x is exactly the same as saying log base m to the x to the nth power. So this moves right there. And all of these rules are the same. Like you can go back and forth. So if you saw something like log base 3 to the 4 plus 4 times 8, you could expand that to be log base 3 to the 4 plus log base 3 to the 8th. These are all, you can go backwards with them. You can condense and you can expand them. Let's see, we also, I think those are the main ones. If I see any others, I will go over them. But that seems to be the case. All right, let's just hop into it. It wants us to, yes, one more. If you have something, and I covered this a little bit in my last video because it was relevant, but if you have something like base m to the log base m, say x, so that's like an exponent, the m and the log base m can cross out, and that leaves you with x. Yeah. So, and then also ln, you'll sometimes see ln or ln. That's exactly the same as log base e. They just gave it a special name because they see e in nature a lot as well. So the ln is sort of like, it's called a natural log. I think it's like French for something crazy. Like that's why it's ln. But it is the natural log. You'll see that sometimes. So in this case, it says evaluate. So 2 to the log 2 to the 7th. This base 2 and the log base 2 will cross out, leaving you with 7. This 5 to the log base 5 will cross out, leaving you with 3. This 8 to the log base 8 will cross out, leaving you with 5. Expand the following logarithms using the property product for logarithms. We have log base 6 to 3t. Now, if you remember, we can do log base 6 to the 3. And since they're multiplying, we can do plus log base 6 to the t. Same for this, log base 6 to the t plus log base 6 to the x. This one is very similar. We'll do log base 6 to the 3 plus log base 6 to the x plus log base 6 to the parentheses t minus 2. That would be your answer. Expand the following logarithms using the quotient property for logarithms. This is about the same property that we've worked with before. So log base 4 to the 3 minus log base 4 to the a. Whatever's on top is the one being in first, and then minusing is the one on the bottom. Log base 4 to the t minus log base 4 to the x. Log base 4 to the x minus log base 4 to the parentheses a plus 7. Expand the following logarithms using the power property for logarithms. This one will have negative 6 times log base 3 to the a, 6 times log base 9 to the x, 4 times log base 7 to the v. Expand the following logarithms using properties of logarithms. Okay, so this one, let's look at this. We have log base 5 to the 2y to the 7th divided by x. What we can do is we can sort of take this one bite at a time. So I'm going to make it so they're separated. So we'll have log base to the 5, 2y 7th, minus log base to the 5x. Now this log base 5 to the x is done. There's no exponents or anything multiplying, but this here can be expanded even more. So we'll have log base 5 to the 2 plus log base 5 to the y to the 7th. And this can be expanded even more. So in the end, we'll have log base 5 to the 2 plus 7 log base 5 to the y minus log base 5 to the x. And that would be your answer for the first one right here. This one, I'm going to write it out, not as in as many steps, but I will still write it out. So we'll have log base 6 z squared minus log base 6 to the y to the 4th. And then these can move. So we'll have 2 log 6 z minus 4 log 6 to the y. And that will go right there. And then for this last one, I'm going to do it without without writing the steps down. For this first one, we'll have log base 3 to the 9, and then plus log base 4 log base 3 to the x, and then minus. Now I'm going to put parentheses over what comes next because that minus happens to all of them, and I just want to make sure that it applies to all of them. So we'll go to log base 3 to the 8 and plus log base 3 to the y squared, which can turn into 2 log base 3 to the y. And then this plus will turn into a minus, and it will look like this because it will the minus will distribute. Yeah, and that would be your answer for that. Combine the following into a single logarithm. Okay, so these two, the insides get multiplied. So first we'll start off with log base 3, and then we have a 4. So 4 times z, and then this 4 here that's multiplying this z will turn into its exponent, so z to the 4th. And that takes care of this part here. That's gone. And now we can divide it by a. That would be our answer. And I'm going to give myself some room. This would be log base 6 to the c to the 6th divided by z cubed. That's kind of harder to see. It's kind of hard to write when there's not a lot of room. C to the 6th. And then this one is 2 plus 3 log 7a. Now this one's a little bit different because I believe that we can't really do anything with this 2. But let me double check. Let me write down. So I still think we'll have a 2 plus, because these two will have the same base. So we'll have 2 plus a cubed times z to the 6th, and it will still have the log base 7. Whoops, let me move that. And let me double check that really quick because I just want to make sure that is what it's asking for. So we'll have 2 plus log 7 to the a cubed z to the 6th. Yep, that's correct. So you can't combine this 2 because it's not connected to a logarithm with the same base. Evaluate the following logarithms. Now, if you remember, if you have a log that has no base, it's always going to be a 10 just because that's what we've decided. So log base 10 to the 10th, that's going to turn into 1 because basically this is our answer. If we converted it back into logarithmic form, it'd be 10 to the x equals 10. X would equal 1 in that case. If it was 10,000, then it'd be 10 to the x equals 10,000, which equals 4. 10s are really easy with exponents and stuff because how many zeros you have is equal to your x. So we have 1, 2, 3, 4. We have 4 zeros, so it'll be 10 to the 4th equals 10,000. It's just counting zeros. And then ln e cubed, my guess would be 3 because we can just get rid of this. Oh, I forgot to mention, you can still do the same thing. It doesn't have to be to the. It can be log base, like if it's log base 10. Wait, no, hold on. No, that doesn't work. That doesn't work in all cases, but it works in this one because we have log base e to the e cubed. I'm pretty sure that's 3. Let me double check just so I'm not talking out of my butt. Hold on. 3. Yes. And then the second one will be just 15. Whoops, I typed in 25. Yeah. In this case, it works. If this was 10 to the 4th, which is the same as 10,000, then it would have been 4 because you could have just crossed that out. Or 10 to the 1st, and it would have just been 1 because you could have crossed those out because they have the same base. It's sort of going back to the rule that we talked about in the beginning where you can cross them out. 15. Evaluate the following logarithms using your calculator. I'm not going to do all of these, and I'm not going to do all of these, and I'm not going to do all of them just because, number one, I don't have my calculator with me. But basically what you do for this, and we'll get into this, on your calculator, when you do log, it will always have a base 10, and if you do ln, it will always be log base e. So these are fine to plug into your calculator. So you would probably get something a little bit less than 2 here. 2, less than 2 still, but smaller. Like you just kind of are guessing. I'm not guessing, but you would use your calculator to plug in log 18 or something. But when it comes to something like this, most calculators that you'll see do not have a base. Like you can't choose your base. It's always log base 10. But that leads us to a fancy little thing called the change of base formula, which is log base m to the n is the same as log, give me just a second to formalize my thoughts. Basically, you can have it be log to the base 10 to the n. The n goes on top, and then log base 10 to the m goes on bottom. You could change that for any base. This is the same for everything. You could change this to like 14 and this to 14. They'll be the same. It's the same. It's changing the base, but this is so you can plug it into your calculator because log base 10 is in your calculator. So you'll do log base, you'll do log and then whatever's in here. So in this case, you'll plug into your calculator log 38 divide by log 20. And I believe when you're typing in a log, it will do log and then open parentheses. So you'll need to do 38 close parentheses divide by log 20, depending on the calculator that you do, close parentheses. And that would be the case. You can just, you put the way I remember it is that it's the bigger one that goes on the top and then the smaller one. Like it looks like if you drew a line, that would be the case anyway. Yeah, that is my little video. If you have any questions, please let me know and I'll answer as soon as I can.